So just so you know, the notation where we use the df dx notation, that notation is called Leibniz notation. So if you see it, or if somebody says, what is Leibniz notation? It's just the notation where we have the derivative written down without the apostrophes, without the number, but instead written down as a fraction with the d and then the dx on the denominator. That's called Leibniz notation. So in the next example number 2, we're going to practice Leibniz notation. So again, very quickly, this df dx, it has basically an invisible 1 and invisible 1. That means they want the first derivative. So let's look for the first derivative of f, the function, with respect to x. And again, we do it term by term. So x to the power 4 becomes 4x cubed, whereas the derivative of 3x squared becomes 6x, and the derivative of 4 is going to be 0. So that's basically that. Now, the d2f dx2, that is the notation for the second derivative. And again, just keep in mind that these 2's are not exponents, so they don't play the same role as an exponent. So we're not squaring the first derivative. We're just getting the second derivative, meaning the derivative of the derivative. So in other terms, I take the 4x cubed and I find the derivative, which will be 12x squared. Then I take the 6x and I find its derivative, and that's going to be just simply 6. d3f dx3, that means the third derivative. And so the third derivative is the derivative of the previous derivative. So the derivative of 12x squared, that's going to be 24x to the power of 1. The derivative of 6 is going to be basically 0. So it's just going to go away. You don't have to write down the 0, by the way. And then finally, the fourth derivative. And again, in this case, the derivative of 24x is going to be 24. And the derivative of 0 is going to be 0, so I'm not going to write it down. So again, you can trace the derivatives, right? So the x fourth is going to give us the 4x cubed, which gives us the 12x squared, which gives us 24x, which finally gives the 24. And similarly, the second term, 3x squared, gives us the 6x, and so on and so forth. And eventually it turns out to be 0. And right away, we can ignore the 4 because the derivative of 4 is going to be 0. It's not going to make any difference. So, you know, on the first line, you could write the 0 if you want to, but you don't even have to. That's basically, you know, useless. So that's basically the end of the question. I hope that made sense.